Assalamu alaikum. In the last video, we have studied the method of production of induced EMF by changing the area of the coil. In this video, we will discuss the energy conservation in the production of induced EMF by changing the area of the coil. For that, I consider a rectangular fixed frame made of some metal placed in a uniform magnetic field which acts perpendicular to the plane of the board in the inverted direction. The crosses represents the inverted perpendicular magnetic field. Okay, and here I take a metal rod AB which is made to move towards the left side with the velocity V. Velocity V. When we do so, suppose after time dt, I say that the metal rod has moved to a new position represented by letters C and D. Okay, what happens? So you can see earlier the area of this loop was large, but now the area has reduced. When the area enclosed by the loop changes, the magnetic flux linked with it will also change. This reduction or change in the area of the magnetic flux. So whenever the magnetic flux linked with a coil or a loop changes, it results in the induced EMF according to third and second law of electromagnetic induction. So the induced EMF here is a representing letter epsilon, and it's nothing but BLV. Here, due to the resistance offered by this loop, an induced current is generated here, and that induced current flow in this direction according to Fleming's right hand rule. Okay, and it is represented as epsilon upon R according to Ohm's law. Now we know the value of epsilon, and it's nothing but BLV. No, I divided by R. Okay, this how we obtain the expression for induced current in this loop. Clear? Now I will prove that it is accordance with the law of conservation of energy. Now before going ahead, let me tell you what is the law of conservation of energy. Law of conservation of energy says that energy can neither be created nor be destroyed, but one form of energy can be converted into another form. This is what the law of conservation of energy says. Here we have generated electrical energy by making certain changes. So I will prove that one form of energy has converted into electrical energy here. So what I have done here to produce electrical energy, I have moved this rod AB towards the left side with velocity V in a magnetic field. When I do so, it means I am carrying out some mechanical work. Now before that, let me explain this part. Here, due to the motion, some induced current flow in the metal rod in this particular direction, that is in the downward direction. Okay, we have studied long ago that a current carrying conductor placed in magnetic field experiences a force. So this current carrying conductor placed in magnetic field will definitely experience some force. This force is known as magnetic force and represented as FB. FB vector, and is found to be equal to the cross product of IL vector and B vector. Here IL vector is nothing but the current element, part of the conductor which carries the current, and B vector is magnetic field. Now when I expand this, when two vector quantities are in cross product, then it can be expanded as IL B sin theta. And here theta is the angle between current element IL vector and magnetic field B vector. Now according to the diagram, here magnetic field acts in this direction along this chalk piece, and current flows in the downward direction. That means they act perpendicular to each other. This is the current element, and this is the magnetic field. They act perpendicular to each other. So the angle theta is nothing but 90 degree. So sin of theta is equal to sin of 90, and its value is equal to 1. This I am going to substitute in the above equation. So what I will get for magnetic field, the B vector is found to be equal to ILB. This is what we obtained if we substitute the value of sin theta from here. Okay. Now, from this it is clear that a magnetic force is acting on this movable rod through which induced current is flowing. Okay. Now, when I try to move this further towards the left side, then this magnetic force which is acting on this rod will try to oppose it. Okay. So some mechanical work has to be done by me to move this further. So for that I need to apply some force. The force that I apply to do the mechanical work is stored there in the form of energy. Okay, let me show this to you. Now the force required to move the rod in the magnetic field is found to be equal and opposite to this magnetic force which acts in the outward direction, just opposite to the motion of the metal rod. Suppose I move the metal rod in this direction, means this magnetic force will act in the opposite direction. So I need to apply a force just opposite to this magnetic force. So as I told you, this applied force is found to be equal and opposite to the magnetic force. So the magnitude of applied force, which is represented by taking the modulus, is found to be equal to the magnitude of magnetic force. And we know the expression for magnetic force is nothing but ILB. That I write from the above expression. Clear? This is what we have done here. Now, I told you to move this one, we need to do some mechanical work. The rate of doing work is referred as power. No, power is the rate of doing work. That I have to calculate now. That is what? Work done in a given time. Rate of doing work is power. Alright, this we have studied in 11th standard, 11th physics. And dW, what is work done? Work done by a force is the product of force and a displacement. If you apply force on something, to what extent it moves is referred as work. So dW, if W is equal to F into S, then dW will be equal to applied force multiplied with displacement. The whole term is divided by time, dt. This can be represented as P equals to applied force ds vector upon dt. We know rate of change of displacement is nothing but velocity. So this expression can be written as P equals to applied force multiplied with velocity. How do we get this term? Let's write this one here. Velocity is rate of change of displacement. D is upon dt is velocity. So from this I have obtained v vector here. Correct. Now we have obtained the expression for power. Work done in a given time. Okay. I box this for better visibility. Now we know the value of applied force that I am going to use here. Now before doing so, write P is equal to applied force and a V vector multiplied with V vector. Now when I expand this, what I'll get this. When I expand this, I'll get P is going to be equal to applied force multiplied with V. Then cos of angle between these two, this is theta. Okay. So here the applied force, the angle between these two is found to be 0 degree. See, we move the rod towards the left side and the velocity is also acting in the same direction. So the angle between these two is nothing but 0. Theta is 0. This is the angle between applied force and the velocity. So cos of theta is found to be equal to cos of 0 now, and cos of 0 is 1. It is known to us. So if I substitute this one here in the above equation, what I'll get? I'll get the value of P to be equal to applied force multiplied with the V. Now we know the value of applied force. Now it's given here. Now that I am going to substitute here. Substituting value. What I'll get if I do so? P will become equal to here the place of F application force, applied force, ILB, and is multiplied with the V. This is the force, and here we know the value of I. It is written as BLV upon R. I take it as a capital I for my convenience, because everywhere we have used the term capital I only. So the small I is replaced with the capital I. We know the value of I. Now from here I am going to substitute. If I substitute the value of I, what I get? P becomes equal to the place of I write BLV upon R is multiplied with LBV. Now as given here. It's taken as such. Then the next step is going to be equal to B square L square V square upon R. This is the final expression we obtained, which represents the power. I box this now. This is the final expression which gives us the work done, rate of work done to move this metal rod in the magnetic field. Okay, so P stands for power, which is nothing but rate of doing work, dW upon a dt. Got it? Now the induced current, which is produced here, flow through this metal rod, this loop. Now I will calculate energy dissipated. Okay. Now, when this electric current flows, we know very well, whenever electric current flows through a conductor, two things happen. One, it produces magnetic field around it, and second thing, it produces heat. We call this as heating effect of current. So, when this induced current flows through this conductor, it produces a heating effect. A heat is produced here. I will calculate the rate at which this heat energy gets dissipated. For that, I write this. Now P, the heat energy dissipated here is calculated as I square multiplied with R. Okay. Do we know the value of I is known? We know the value of I is found to be BLV. BLV upon R. The whole square is multiplied with the capital R. Okay. Then the next step what we get that P 1 to be equal to B square L square B square upon R square. Already I have R here, so these two things get cancelled. And what do we obtain is nothing but this. Okay, I bounce this. Now, I name this as equation number 1 and this is equation number 2. Now, if you compare equation 1 and 2, you'll find both appear similar to each other. This clearly shows that here it represents the rate of Rotan bias to move the rod in the magnetic field, and this represents the power, the heat energy dissipated at any given time. Okay, and these two found to be equal to each other. This clearly proves that whatever work we have done to generate electrical energy has converted into heat energy, and it is dissipated. This is what I will show. So from this, it is understood that one form of energy has converted into another form of energy. Here, the mechanical work done by us against the magnetic force has converted into electrical energy, and that electrical energy, when it flows through the conductor, gets converted into heat energy. So this clearly shows that one form of energy has converted to another form of energy. So the energy which is generated here has not come from nowhere. So this clearly shows law of conservation of energy. I hope the video is useful. If you have any kind of doubt related to the topic, can you put a question in the comment section. Thanks for watching.